Let's see how this goes. You want your calculator out, and I'm going to try and teach you some trig. If you don't have a calculator, you got a calculator here? It is there? Okay, good. Now, here's the good news. You'll be getting crazy good at trig in Physics 12. In fact, you'll reach the point where I'm hoping you get good enough at trig that it reaches, don't write this down, the same point as that equation would be. Let's make that a 6 so you can read my writing because that looked like an S. What's x in your head showing no work? I'm hoping the trig gets that boring where you really do it, plus the 6 over, and we're good. So we'll get there next year for sure. Projectile is launched from the ground at an angle of 36 degrees with a velocity of 89 meters per second. It says dulp. Ground. Draw that. 36 degrees. Well, first of all, don't write this bit down, but for what it's worth, how many degrees? 90. What's halfway? So I'm eyeballing roughly 36-ish as about like that. I wouldn't write it like that crazy big. I wouldn't write it crazy small. And we're going to label that 36 degrees, and we'll call that 89 meters per second. And can you imagine, please, Christy, that I think the projectile, sorry, that's a bad drawing, it's going to follow a path something like that. Don't draw that in, but use your imagination. What we're going to ask is, where does it land? That's our goal. Don't draw that in either. This is at an angle. We don't do physics with stuff at an angle. We're going to break this into components, and that's why A says find the horizontal and vertical components of the velocity. I'm going to give you a different way to think about this. Draw the 89 again, like that. But I'm going to argue that you can think about this as moving sideways and moving up and down at the same time. So I drew a horizontal dotted arrow pointing to the left and a vertical dotted arrow pointing up, because I think that's what's going on. It's moving to the, I said to the left, to the right. It's moving to the right, and it's starting out moving up. Which one did I put an initial on? Why did I put an initial on the x? What's the horizontal acceleration? Who remembers? 0. So horizontally, that's not going to change. But vertically, it's going to slow down, At the top for a split second, what will its vertical velocity be? 0. And then it's going to speed up, become negative, become bigger, negative, become bigger, negative, until it hits the ground again. Put the 36 degrees right there. Every triangle has 3 sides. And I'm not saying that to be Captain Obvious. I'm saying every triangle has 3 sides. We are doing something called right-angled trig, and in right-angled trig, you have a right angle. Draw that in. What do I call the 89? It begins with the letter H. Okay, so this is the hypotenuse. Just label it with an H. Then in trig, there are 2 more sides. There are the opposite side, and there is the adjacent side. I tend to abbreviate. I'm going to use the letter O for opposite and the letter A for adjacent. One of these is the opposite side and one of these is the adjacent side. Right now, Chloe and I are opposite each other. We're facing each other. So we always start with the angle, and if you go out from the angle, right there, that's the opposite side. Right now, Christian and Mateo are adjacent to each other, beside each other. It always goes back to the angle. This is going to be the adjacent side. Now, don't write this next bit down. It all depends on where your angle is. If my angle was right there, this is still a hypotenuse, but that's opposite. That's adjacent. So you can't, Tristan, just memorize, oh, the bottom side's always adjacent. It always depends on where your angle is. The opposite side is the one across from the angle. The hypotenuse is the long skinny one. The adjacent side is the one beside or touching the angle. And that's why I used those expressions. You two are adjacent, you're beside each other. Opposite is facing. The hypotenuse is the long diagonal side. We have an acronym in Trig. You're going to write this down, please. It goes like this. S-O-H-C-A-H-T-O-A. The S stands for sine, which is one of the buttons on your calculator. It's pronounced sine, not sin. Sin is when you call sine sin. That's a sin. Call it sine, please. Sin is when you swear in my class. Sine is the trig function. The C stands for cosine, and the T stands for tangent. And as fractions, the sine of an angle is equal to the opposite side divided by the hypotenuse side. That's what the SOH stands for. Cosine is adjacent over hypotenuse. That's what the A and the H stand for. Kids have been using these acronyms for well over 100 years. Tangent is opposite over adjacent. And you have all of these values, all of the sine and the cosine and the tangent values built into your calculator. We want to find the vertical component. The vertical component is going to use those two, don't circle them, those two right there, because I know the hypotenuse, I know the 89. Vy, opposite or adjacent? Opposite. So I have an O and I have an H. Which trig function has the O and the H and nothing else in it? The S, which stands for? So everybody, we're going to write this down, please. Sine. What always goes next to the trig function? The angle. What's the angle in degrees? Equals opposite, Vy initial, over hypotenuse. How would I get the Vy by itself? What will I do with that divided by 89? Okay, now, we need to make sure all of your calculators are in the same mode because there are different ways to measure angles. How many degrees are there in a circle? 360. Another way you can measure angles is in radians. There are 2 pi radians in a circle. Radians are way better, except for doing math in your head. They suck. Everywhere else, they're better. You can also measure angles in gradians. There are 400 gradians in a circle. 100 gradians equals a 90-degree angle. If you've, because it's out of 100, that makes it a percentage. If you've ever been on a road and you come to a big hill and the sign says trucks gear down and then there's a percentage underneath that, they've measured that hill in gradians. It's a percentage grade. Okay. So we need to make sure you're all in degrees. On most of your calculators on your screen, there's going to be a little lowercase d. If you see a little lowercase r or a lowercase g, you're in trouble. Now, if you're not sure, here's a trick that always works. If you type sine 30, you don't have to do the bracket, and hit equals, you should get 0.5. If you don't, you're in the wrong mode, and I will come and fix that right now. Let's get the Vy initial by itself. I think Vy initial is 89 sine 36. Or sine 36 times 89. I tend, instead of typing sine 36 times 89, because I'm never sure if my calculator thinks that that 89 is part of the angle or not, I almost always put the 89 in the front like a coefficient, and then I go sine 36. What do you get? To, let's say, 4 decimal places, or 4 or 5 sig figs. I'm going to go 52.313. And the reason I'm carrying extra sig figs is, although you don't know this yet, I'm going to use this again. So I don't want to round off and then use a rounded off answer to find another rounded off answer. We're going to come back, but let's make a t-table. What were the two things that I could put in this t-table that I called my physics no-brainers? What was the horizontal acceleration? What was the vertical acceleration? And I now have something else I can add in the vertical column, 52.313. I need three things to find time, so clearly we need to keep going. We're going to go back and we're going to find Vx. Now, Vx, don't write this down. I'm going to use those two. I'm going to use adjacent and hypotenuse. Which trig function is the A and the H? Of course it is. What always goes next to the trig function? The angle. And it's going to be adjacent over hypotenuse. How would I get the Vx by itself? Okay, I'm going to have to do that on the same line. So Vx is going to be 89 cos 36. Stop, look up, look up, look up, look up, look up. Have I gone on a rant about getting a good calculator occasionally? Almost every one of you should be able to just hit your backspace button and change the sign to a cosine and save yourself some typing. And I get 72.003. And I can put that in my t-table as well. Brian, how many things do I have on the left side of my t-table? How many things do I have on the right side of my t-table? Not enough. The rest I have to get there from my knowledge of physics. There is something else that I know, and there's a candy. If anybody can come up with it, I'll give you a hint. It's going to be in the vertical column. I know something else vertically. Yeah. Vertical final equals 0? Well, it's 0 at the top. Are you saying the top is final? Well, it's not 0, because if you do a belly flop onto the ground, it'll hurt. Mateo. Because what goes up must come. What goes up must come. Thank you for filling in the line after the cue. Ryan, how many things do I have on the left side? How many things do I have on the right side? I can find time, because I'm going to spend most of my time finding time. So, t equals question mark. A is negative 9.8. V initial was 52.313. And V final was negative 52.313. I'm looking for an equation that has T, A, VI, and VF in it. You know what? I should be careful. I'll put the Y's there just to remind myself. Make sure I use vertical. Don't use a horizontal in a vertical equation. Don't use a vertical in a horizontal equation. That's the no-no. So I put those Y's there just to remind myself. Make sure I'm pulling this from the Y column. What is the equation that has that? Christian, loud and proud. VF equals VI plus AT. Can you get the A by itself, please? Sorry, the T by itself, please.
VF minus VI over A.
And I get negative 52.313 minus 52.313 all over negative 9.8. By the way, Mateo, you could let Vy final be 0. That would give you time to top. How would I get total time? Take time to top and do what? Times by 2. Because time to top and time to bottom, because we're starting and ending on the ground, will be the same. But I'm lazy. I'd rather get there in one step, especially because I have this number in front of me, so it's going to be negative. Oh, is this a fraction, Christian?
Yeah.
More than one thing on the top? Brackets. Negative 52.313 minus 52.313. I started to get... Sorry? 53. I started to get nervous here because the top is going to be negative and I want time to be positive. But then I went, oh, no, because I'm dividing by negative. I get a negative divided by negative, which is a very positive. Time of flight is 10.676 seconds. What's D want me to find? The range. Is that horizontal or is that vertical? Horizontal. You know what? It wants me to find dx. So I already know ax. That was 0. Yes? I've scrolled down. What was vx? Someone read it to me, please. Sierra? 70... That's only 2 things. I need 3 things. Oh! You're telling me that I can just drop the time right there and I'm so lazy I didn't even bother writing it. I just drew an arrow. I'd figure that out. Looking for an equation that has a D and A, a V and a T in it. There is one. Which one? Christian, you're on a roll. Keep going. You're going from memory, are you?
Yeah.
Okay, you're a bit off, so you were on a roll, but now you've come crashing back to reality. Oh, sorry, that came out wrong. Anyone? So dx equals vxt. Why was I so lazy? Why didn't I even bother writing plus a half at squared? And by the way, by far the most common mistake, kids want to put the 9.8 there because they don't like the acceleration being 0. There should be an acceleration. Vertically, there is. Horizontally, we're just going, plugging along. And Joel, we get 72.003 times 10.676. Although I think I still have this stored on my calculator, so you know I'm going to use my answer button, right, Maggie? So here is the physics of, for example, World War II artillery cannons. What angle are we elevating it at? We know the velocity coming out of the cannon. Where's it going to land? Although what you would be actually doing is figuring out what angle to elevate it at, because you would know where the target was, so you would reverse engineer this to find the angle. A little trickier. You get 768 points. I'm going to call it 769. Ooh. Find the maximum height. Height. Rihanna, do you think that's vertical or horizontal, the word height? So I'll make a little note. AY was negative 9.8. Oh, we got a latecomer here. What was VY initial? Was that was 50 something, what, I got it up here. 52.313, not negative because it was on the way up. Is VY final negative 52.313 at the top? Mateo, what's V final at the top? Oh, I like that. And we'd like to find do I know 3 things? I can find the 4th. I bet you there is an equation that has an A, a V initial, a V final, and a D in it.
VF squared.
Get the D by itself, please.
D equals VF squared minus VI squared over 2A.
And again, I won't be fussy if you don't put the y's in. I just do because I think it's wise. Nothing. Okay. It's easy to put the horizontal into a vertical, and that's what I'm paranoid about. Why? Nothing. Wow. So it's going to be 0 squared. I can probably do that in my head. Minus 52.313 squared all over 2 times negative 9.8. The other thing is this is a nice review of some of our kinematics stuff. Zero squared minus 52.313 squared divided by 2 times negative 9.8. Do you get 140? If I go to 3 sig figs, 139.6, I'll go 140. Example 2. I think we're going to try and get away with just doing one more, and then I'll tell you exactly what's on your final exam from this lesson. Find the range for a projectile launched from the ground at an angle of 57 degrees with a velocity of 321 meters per second. I'm an adult. There's the ground. There is 57 degrees, 321 meters per second. I'm not going to use that 321 in my t-table. I don't use stuff at angles. I'm going to break this up into components. I'm going to break this up into a horizontal and a vertical component. That 321, opposite, adjacent, or hypotenuse? Hypotenuse? What about Vy initial, opposite or adjacent? What about Vx? Let's find Vy. To do that, we'll use those two there. Don't circle that. Looks like I have an O and an H. Which trig function is that? Now, a good habit to get into, have we all just turned the page? At the top of the page, when I taught trig, I always had my kids, every time we turned the page, we wrote that at the top. It gave us our handy reference because it took all of 1 second, and we knew we were going to be using it several times anyways. So now that I've written that, which trig function? Sine. What always goes next to the trig function? The angle. And that's going to be opposite over hypotenuse. I guess to get Vy by itself, I'll times the 321 over. By the way, my calculator, some of your calculators, some of the TIs in particular, as soon as I press sine, it automatically does an open bracket, so I have to close the bracket. Probably you don't need to put brackets around them, but it's not a bad habit. You get 269.21. My rule of thumb is I usually carry 5 sigs, because if I carry 5 sigs, my final answer should be good to 5 sig figs. If I carry 5 sig figs, I'm usually going to be good in my final answer to 3 sig figs, which is about as accurate as I care to be. So 269, is that right? 269.21? Mr. Dulac? What, Dylan? I noticed Vy here was sine. Yeah. Mr. Dulac? What, Dylan? I notice Vy here was sine. Yeah. Will it always be sine? If we're launching from the ground upwards, yeah. Mr. Duick. What, Dylan? Can you give us a dumb way to remember that Vy is sine? Mr. Duick, do you have a stupid way that I can remember that Vy is sine? I got nothing. You're on your own. Haven't come up with anything. Sorry. Mr. Duick. What, Dylan? I noticed that Vx is cosine. Of course it is. Stuff you won't find in the textbook, but stupid tricks of the trade that work. So if you had to make a guess, Dylan, which trig function is Vx going to be? Of course it is. In fact, you may even be clever enough to say, I think Vx is going to be that number cos that angle. So I'm going to tell you a question on your final. You ready? On your final, I gave you a question that says projectiles launched from the ground at an angle of something, something, and I said find the vertical and horizontal components of the velocity. How will you find the vertical, the Vy? Sine? How will you find the x? Cos. That's one multiple choice question. I just have a little chart that you pick the correct ones from. Okay? I think that's all I put on your final exam for angles. I don't think I actually asked a question to find the range, but I'll check at the end of this lesson because I didn't realize that you folks haven't seen much trig. Anyways, oh, Mr. Duick, just backspace. Change it. Oh, heck yeah. I get 174.83. Good. Hannah, what does this question want me to find? I'll give you a hint. It says find. Okay, thank you. A little worried there. I thought that one was a little Captain Obvious, which is dx. What am I going to do next? Yes, t-table. Good. So, horizontal. You know what? I'll change colors just so it stands out a little bit. Horizontal, vertical. My physics no-brainers. By the way, that little line right there would make a good multiple choice question. Which of the following is true? AX is 0, AY is negative 9.8, AX is negative 9.8, AY is 0. Mix and match those. That would be a good multiple choice question. I think that's on your desk. What else can I write? I guess I have VX is 174.83. Vy initial is 269.21. I only have two things. That's not enough. What else can I write? Because what goes up must come. By the way, Christy, in my original diagram, what was the slanty velocity? What was the original velocity the question gave me? How many meters per second? We never use that, and that's another common mistake. People think, isn't V initial 321? No. We go components now. Once I do the trig, as far as I'm concerned, that 321 no longer exists. I say to it. Christian, what was the time equation? Oh, it was VF minus VI over A. Yeah. So negative 269.21 minus 269.21 all over negative 9.8, brackets around the top. Negative 269.21 take away 269.21. I get 54.94. 1. Hannah, is that what they want me to find? Time of flight? What do they want me to find? Oh, they want me to find a horizontal, which means I'm going to use I wrote AY. That would have been silly. AX equals 0, VX equals 174.83, and time equals, see how lazy I am? Hannah, which equation can I go with here? Of course, I'm going to use my answer button. 174.83 times answer button. Wow, this thing's gone. Oh, you know what? 321 meters per second. That's just shy of the speed of sound. This sucker is going to take off, and it's going to be traveling for a while because this goes almost 10 kilometers. This would be probably an artillery shell of some type. 9,600 and I guess 10. Yes, if I round to 3 sig figs. I'm going to skip example 3, and I'm going to say you can now try number 1. Number 2 is horizontally from a cliff. I crossed out B here, didn't I? This was nice because we went to the moon, so we used G as 1.6, and Alan Shepard did actually smuggle a golf club aboard on Apollo 14 and did play 1 round of golf on the moon. You know that? Yeah, he did. For the golf handle, he used a shovel, but he smuggled a club head because all the weight was pre-measured out, but you're allowed to bring like 1 pound of personal items or something like that, so he chose to bring a driver head. And he did hit a a couple of golf balls on the moon. Still there, because we landed there. Just saying. 3. And I think I'm just going to pause there. I don't want to give you too much homework because I have something else.